In this video, we will learn about identification of anions, and the identification of anions will be done by adding dilute sulfuric acid. So the first anion that we have to detect is carbonate. The procedure that we will follow for the detection of carbonate is, first we will take small amount of salt in a test tube and then we will add some amount of dilute H2SO4. After that, we will heat it. On heating, we will observe a brisk effluence. This is due to the formation of carbon dioxide as a product of the reaction between sodium carbonate and H2SO4. The product that we will get is Na2SO4, that is sodium sulfate plus H2O plus carbon dioxide, and this reaction is an example of double displacement reaction. As a result of which we can conclude that carbonate is present, but even after concluding that carbonate is present, we have to again confirm that whether carbonate is actually confirmed or not. For that, we will pass the gas, that is CO2, from freshly prepared lime water, and we know that lime water is CaOH whole twice, and when CO2 passes through it, we know that lime water turns milky due to the formation of calcium carbonate. And as a result, we will get calcium carbonate in the form of a precipitate and water. For the confirmation of carbonate, we have to again pass continuously in excess. The gas has to be passed continuously in excess. So when CO2 is again passed over CaCO3 plus H2O, it will result in the formation of CaHCO3 whole thrice, that is calcium bicarbonate. Initially, we had CaCO3, which is not soluble, but as a product we are getting CaHCO3, which is calcium bicarbonate. It is actually soluble. The milkiness disappears because as a result we are getting CaHCO3, and hence we can confirm that carbonate is present. The next anion that we have to detect is sulfide. For detection of sulfide, first we will take small amount of salt in a test tube, and then on addition of dilute sulfuric acid, we can see or we can feel a rotten egg-like colorless gas is evolved. This gas is actually H2S. So coming to the reaction, when PbS plus H2SO4 reacts, we get PbSO4, that is lead sulfate, and H2S gas, and this is actually a gas which is colorless and it smells like rotten egg. As a result, we can conclude that sulfide is present, but still we have to confirm that sulfide is actually present or not. So for the confirmation, first we will take a filter paper and then we will dip it in lead acetate solution and then we will expose it to the gas. The reaction will be as follows, that CH3COOPB, that is lead acetate solution, plus H2S will give us PbS, which is actually black in color, and as a result we will see that filter paper is actually turning silvery black, which confirms that sulfide is actually present in that particular salt. The third anion is sulfide. For checking whether sulfide is present or not, first we will take small amount of salt and then again we will add dilute sulfuric acid to it. As a result, we will see that a suffocating colorless gas is evolved. This is actually SO2, and this confirms that sulfite is present. But for the confirmatory test, we have to again moisten the filter paper with acidified potassium dichromate, and then we will expose it to SO2 gas, which changes the orange color of potassium dichromate to green as a result of formation of Cr2SO4 whole thrice, and hence we can conclude that sulfite is actually confirmed that it is present in the given salt. I hope this topic is clear to you. Thank you.